This is section 8.4, part 1. And in section 8.4, part 1, we're talking about angles of elevation and angles of depression. And as we look here, our objective here is to use the angle of elevation and angle of depression to solve problems. So, you'll notice in the picture here that we have, you'll notice that we have angle of depression and angle of elevation. Okay, obviously, angle of elevation, you're looking up. Angle of depression, you're looking down. So you're high and you're looking down. And you'll notice that from this picture, that the angle of depression and angle of elevation, if I go through here and I trace this and follow this, this would be my triangle that I would be using. In this case, my right triangle that I'd be using. The angle of elevation is always the angle where you start from the ground up or from eye level up, whatever it may be, depending on what kind of situation you're in. And angle of depression is always outside of the triangle here. It's always outside of the triangle, and it's always looking in a downward direction. Now, you'll notice some things that you'll see here. These two lines happen to be parallel. So because they're parallel, this angle right here and this angle right here are equal to each other. So essentially, the angle of elevation is equal to the angle of depression, because they're alternate interior angles. Now that takes you back a ways. We haven't talked about that for quite a while, okay? But anytime they give you the angle of depression or angle of elevation, they're always going to be equal to each other, okay? So here's your right triangle, and you'll notice your angle of elevation from the bottom up. Angle of depression is outside of the triangle, but you'll notice that these two angles are the same. Okay, now, using the concept of angle of depression and angle of elevation, okay, we're going to be able to find different distances. Okay, so for example, it says here you can use the angles of elevation and depression as the acute angles of the right triangles formed by a horizontal distance and a vertical height. So you're going to be able to find horizontal distance, which is from left to right, or vertical heights, which is up and down. Okay, so let's take a look here at the first example. It says, suppose you stand 53 feet from a wind farm turbine. For those of you who don't know what a wind farm turbine is, it's the big windmills as you're driving maybe along the interstate. You notice down by Lincoln on the interstate, they're the big windmills. That's what a wind farm turbine is. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is at 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? Okay, so you'll notice on your sheet you don't have anything here. Well, the very first thing that we need to do is draw a picture. So what I've done is I've drawn you with my wonderfully awesome artistic abilities here. Don't be stealing anything here now. A great picture. So here's our person here, our 5.5 feet tall person. In other words, they're very short. No offense to you shorter people. Okay, but they're 5.5 feet tall, and you'll notice here's my wind turbine I've got right here. It's a wonderful looking wind turbine. That thing's going like crazy through the wind. And the information that it gives us is, suppose you stand, you're 53 feet from a wind farm turbine. So from the turbine to you, it's 53 feet. So I'm going to go ahead and label that on our triangle. Okay, so that's 53 feet. It also says your angle of elevation to the hub of the turbine is 56.5 degrees. Well, if you remember, elevation goes from your eyes up. So in this case, this angle right here is 56.5 degrees. Okay. Your eye level is 5.5 feet above the ground. Okay. So that's 5.5 feet. What it wants to know, how tall is the turbine from the ground to its hub? So what we want to know ultimately is how tall the turbine is. Well, in order to figure out how tall the turbine is, we have to figure out this distance from the eye level to the turbine. And you'll notice, as you look at this here now, that you have a triangle that's a right triangle, and you have an angle and two side measures. So again, you're going to be using your trigonometry here. So from the angle, you'll notice that you have opposite and, in this case, adjacent. So we're going to be using the tangent function. So the tangent of 56.5 degrees equals opposite, which is x, over adjacent, which is 53. And now to solve, we multiply by 53 on each side. Okay? And then I'm going to take 53 times the tangent of 56.5, and that's going to equal x. So now when I go ahead and multiply that out, I get x to equal 80.07. Now, it does say how tall is, in your directions here, approximately. So everything round to the nearest whole number. So in this case, x is 80. Okay. Now, as you look at that, does that mean that that's how tall the wind turbine is? No. What that means is that this is how tall it is from eye level to the turbine. So what I have to do with my 80 is add the 5.5 amount of height that's left over. And in this case, the wind turbine is 85.5 feet tall. That is my answer. Okay. So you're using trig and you're trying to apply it to a real life situation. Okay, second question. It says, you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground, and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? And you'll notice again, you've got another one of my beautiful sketches. Okay, so what I'm going to do is I'm going to put the information in here. I've already got that the person is 6 feet tall. It said that the angle of elevation was 32 degrees, so go ahead and put that in there. And it says the distance from you to the base of the cliff is 1,000 feet. And what we want to know, what is the approximate height of the rock climber to the ground? We know this is 6 feet here. Okay. Now, which means we need to find that length. Now that I have this filled out, what I want you to do is hit pause and see if you can complete this and get the correct answer. Okay, now that you've hit pause, let's take a look at this example. Again, in this case, from the angle, you have opposite and adjacent. So again, you're going to use the tangent. Tangent of 32 degrees equals opposite, which is x, over adjacent, which happens to be 1,000. And when you take 1,000 and multiply it on each side, you get 1,000 times the tangent of 32. That's going to equal x. When you multiply that out, you get 624.9 equals x, which we're going to go ahead and round that to 625, rounded to the nearest foot. So if I take the 625, is that the height? No, I have to take the 625 and add it to the extra 6 feet that I have from my eye level to the ground, and that's going to give me 631 feet off the ground. Okay, let's take a look at the third one now. Again, what I want you to do now is I want you to see if you can calculate this number 3 on your own before I put anything in there. And then, again, hit pause and see if you can come back and get it correct. Okay, now that you have hit pause, let's take a look here. It says, to approach runway 17 at the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth, how far from the runway is the airport at, or is the airplane at the start of its approach? So it says in the problem it has a 3-degree descent. That's a 3-degree angle of depression. So you'll notice, you see where I put the 3 degrees in here. Okay, so I put the 3 degrees in our picture here at our angle of depression. Now, you know that if the angle of depression is 3, that the angle of elevation is 3 as well. And you'll notice I have sea level in here too. So it is 1,007 feet from sea level to the airport. This right here is the airport. Okay. It's also 2,714 feet above sea level. The plane is when it starts its descent. So in order to figure out this distance right here, we take 2,714 and we're going to subtract 1,007. And that's going to give me 1,707 feet. So this distance right here is 1,707. And we want to know how far out is the plane from, how far away from the runway is the plane at the start of its approach. Okay, so as we look at this example, again, in this case we have a tangent issue because we have opposite and we have adjacent. So I'm going to use the tangent of 3 degrees equals the opposite of 1707 divided by the part that I don't know. So in this case, I'm going to flip them. X equals 1,707 divided by the tangent of 3. And when I do that, you end up with 32,576 feet away from the airport. Okay, so here's what I want you to do. Before you come to class tomorrow, I want you to take a look at this last problem. I'm going to have you do this completely on your own. I want you to come to class with an answer to this last problem. This will be the very first thing that we discuss when you come in tomorrow to class. Okay, this concludes section 8.4, part 1, WSQ. Make sure you fill out the WSQ as well.